Hi everyone, I'm Swapna. Today we are going to see a project, an embedded system project on microwave oven simulator project. We are implementing this project using Picsimlab and maplabxde, where we use a compiler called Xe8, and it's a team project where my teammates include Gopi and Harini. We are from the Anand College of Engineering, and I'm studying my BTech in Bachelor of Engineering in ECE department. I'm currently in my 4th year. So when we go to the what exactly we're going to learn in this video is about the introduction, objective, requirements, tools, simulation cases, and the simulation, how exactly the microwave and simulation works, and the conclusion. So when we come to the introduction, first of all, what is microwave oven? We already know that microwave ovens have become an very important device in our daily lives, because we know, like, for the rapid heating and for cooking our food we generally use microwave ovens. They are basically the straightforward kitchen appliances where not the heavy technology but a basic technology is being implemented. So in this report we'll be using the inner working of micro oven, exploring their operation and realizing it through a real-time system using the Picsimlab. Basically, a microwave oven have four modes. They are micro mode, grill mode, convection mode, and the start mode. When it comes to the micro mode, it cooks food in a traditional way. Like, it generally uses the power of 900 watts, and the maximum time for cooking food is 60 minutes, that is 1 hour. When it comes to the grill mode, it is same as micro mode, but this mode is generally used to cook food which requires heavy cooking, like the food items include meat and bread. When it comes to convection mode, this is a mix of both micro mode and the grill mode, where the time limits are lesser than both of them, and we generally focus on the temperature. This is basically for the preheating of items, the food items. It almost takes some 3 to 4 minutes. Then when we come to the main objective of this project aims to simulate the behavior of a microwave oven using Picsimlab, and as I told, we are using the software called maplabxde with an Xe8 compiler. Through this project, the main 3 goals we are going to learn is, we are going to gain insights in microcontroller programming, because the coding we have done is mostly on embedded C, and we are learning about the simulation techniques, how we have to run the code, how we have to dump the code and all. And later it's the real world application of embedded systems. So we'll come to know about the real world applications and we'll be applying our knowledge. When we come to the requirements to make this project, like to simulate this project, we require maplabxde, Picsimlab, a 16x4 CLCD, a tactile switch, and MKP. Even we need timers. We use the compiler Xe8, and the mode in Picsimlab is PIC16F877A, and this is the most used mode. Before going to our project, we'll first get an basic information on the embedded systems. An embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function, a specific function generally. Embedded systems have so many categories, like it has standalone system, real-time system, networked system, mobile system, and in this project we are focusing on the real-time system. When it comes to in embedded system, the main topics include microcontroller and when coming to microcontroller and microprocessor, microcontroller is an integrated circuit IC which is being programmed for a specified task with design restrictions such as memory size and peripheral function. So basically these are the restrictions we have in microcontroller, majorly which includes memory size and the peripheral function. When it comes to microprocessor, it's a computer processor which includes microcontroller where data processing logic and control is included in a single IC. These are the major differences between microcontroller and microprocessor, and these are the basic units in an embedded system to work on. So in this project particularly, we are using the tools named maplabxde, Picsimlab, CLCD and MKP. We even used interrupts and timers. So when coming to maplabxde, it's an integrated development environment which is expandable, highly configurable software program. This powerful tool helps us to discover, configure and develop. It even helps us to debug and qualify embedded designs for most of our microcontrollers and digital signal controllers. So when it comes to Picsimlab, Picsimlab is a real-time emulator for PIC and Arduino. Picsimlab is an emulator of development boards with an integrated maplabx debugger. This supports some Pixim microcontrollers, and this is the basic Picsimlab. So the board, and this is the architecture which includes RS-232, LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD, ADC, LM35 temperature sensor, RTC and EEPROM, GPIO, General Program Interface. This is the basic architecture of our Picsimlab. When it comes to CLCD, character liquid crystal display, it has two displays, 16x2 and 16x4. When it comes to the communication mode, it has two modes, 4-bit mode and 8-bit mode. MKP, matrix keypad, when more number of inputs are required and it still wants to control the inputs, we use the matrix keypad where we generally control the output. And these are mostly used in our telephones, calculators and lockers. This is the basic MKP. These are the switches and these are the tactile switches which we came upon before. And the major part includes over here, it is the interrupts and the timers. Interrupts, an interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requires MPU or MCU to stop processing. Like it will advise the thing to stop process. Then later when it comes to a acknowledgement that something has happened and it has to recover it, then it will again request and attends the previous request also. This work in a process where it has to come up with an idea to just wait for a result and then go for the previous one. Acknowledgement, the basic function. Then we have timers and counters are the very important applications in embedded systems which are basically used to calculate delay and the measure time. It's a software designed to count the time intervals between the events. This is the time interval between the events is called a resolution. It is also called as a register width. It denotes the up or down counter. Basically the up or down count is called as quantum. The scaling may be pre-scalar or post-scalar. So when we go to the simulation part later, we'll come upon so many cases, and these are some of the cases which includes power on, like it displays a power on CLCD. we have modes as we discussed before: micro mode, grill mode, connection mode. Sorry. As I said earlier, we are looking on the 4 modes which will be displayed on CLCD: the micro mode, grill mode, convection mode, and the start mode. So this is the start mode, where we come across the time, the resume time, and the pass and the stop. And this is the final phase where it displays timer. So we'll now look into the simulation part. I'm going to open the maplabxde version 6.15, where I have written the code. These are the header files, important files, these are the linker files, and these are the source files, libraries, and everything. So you can see here the build is being successful and the load is being completed. If you want, I'll explain the code even. So this is me, Swapna, and as this is a watchdog timer, as we are not using the watchdog timer, I have been made it as off. So when these are the things, when time is 0, when it is immediate on, it has to display a thing called as power is on. I'll show that in the Picsimlab simulator later. So when we come to the void function, here we have made the fan as off, then later off. When the timer is on, we made the buzzer as on. After a delay, after setting the time, it will be on again. And when it comes to the main function, we have set the power to the 900 watts, and we have made the key one as micro mode. So when I click on one, the micro mode will be initiated or activated, and I have made the key 2 as the grill mode. Same usually, when I click on 2, grill mode will be on. 3 is for convection and 4 is for the start mode. So basically in the convection mode, the temperature thing goes on. For the start mode, whatever the seconds we give on, it goes for 30 seconds. Like for the both for the both micro mode and the grill mode, we will set the time, but for the start mode, it usually takes the time as 30 seconds, and we can even change it. I'll show everything in the next slide of the Picsimlab simulator. And I have made start, enter, and clear buttons even. So this is the function, this is the thing which happens, and later, and this is the overall look of the code. That's it. If you want, I can build it again. I'm going to build it again. It has been showed as build successful. So I'm going to the Picsimlab simulator. Here, see, I have set the frequency as 20 megahertz, and the LCD file includes this thing where it is 16 cross 4 display. And as I said it earlier, if you want, I can load the file again. I'm loading the file again. You can see the powering is on and the microwave and being on, and all the modes get displayed. As I said before, the one indicates the micro mode, and 2 the grill mode, 3 the convection mode, and 4 the start mode. This is the displays, and this is the CLCD, and these are the matrix keypad, and these are the tactile switches. These are the LEDs, and these are the heater, and this is the buzzer. So okay, let me turn on micro mode now. It shows the power as 900 watts. I'm setting the time as 10 seconds. and I'm clicking on enter. So you can see the timer being running down. After 10 seconds the cooking will. Sorry, a glitch happened before. I'm going to do the micro mode again. Power is as usual 900 watts. I'm giving the seconds as now. Okay, let me give it as 10 again, and I'm clicking on start. You can see the timer being running down. So after 10 seconds we can hear a buzzer sound indicating the food is being cooked. So this is the buzzer. Now I'll go for the grill mode. As I told already, grill mode is used basically for the specific cooking items, for the deep cooking items like bread, chicken, everything. Okay, let me give 5 seconds now. I actually takes more time, but I'm giving it less time. You can go for the high time. Usually in a real-time application, as it really cooks the heavy materials, it takes the longer time. I'm clicking on enter. So after 3 seconds, sorry, 5 seconds, it has to burst. And you can even go for the convection where the temperature is being set. So it preheats the thing, and after 15 seconds, as we set immediately as 15, again a buzzer sound occurs indicating the preheated items are being preheated so properly. It's done. I'm going to set the time so that it will be cooked now. Okay, sorry, I'll make it 10 seconds. Yes. And now, before it's been preheated, now it will be cooked. Yes. Now we'll go for the start mode. As I said earlier, it has a pre-setting time of 30 seconds. So you can see the time is been running down from 30. It goes till 0, then we'll have a buzzer sound indicating the thing is done and the food is ready to be served. This indicates a very useful real-time application, and this is an example of the embedded systems. You can see the relay one being on when the buzzer being oning. That is the main thing to be noted down, and these are the 4 modes. So I'll go to the my presentation, and we have seen the simulation. When we come to the conclusion, from this project especially, we have learnt about the embedded system, real-time working system, but entirely in this internship we have learned for the first week the introduction to C, which includes the conditionals, loops, operators, arrays, pointers, functions, strings, all embedded C. And later, after 2 weeks, we had gone to the embedded systems and the microcontrollers, where we have used the knowledge of C and dumped it together, coded together, worked together, and implemented this project in this embedded system. As I was saying, from start we have used maplab IDE, X8, Picsimlab, and we have gone through many peripherals like PIC 16F877A. And from this internship, during this internship period, we have given many quizzes, we have attended the classes, and those classes were really effective. And I'm really interested to do a project in embedded systems afterwards also. And if you like this presentation, do please like this video. And thank you, Emma for giving this opportunity. Thank you so much. And for the last time, I can just go through all the slides. And I'm again thanking the Emertex for giving me this opportunity and making me know of all these things. And yeah, these are the, I'm to quickly go through all the things. So I can even go through the maplabxde IDE. And clearly seeing the build is being successful. The files and go through the Picsimlab. Yes, this is the. Thank you again. Thank you